writing assembly code for 32-bit machines, and here you just do 64-bit assembly. So you install YASM, and here's syscall1 write, which we've talked about before. This is how you make hello world. So you have to set, this is 64-bit though. So you go here, and you see RAX is the syscall, so RAX has to be 1 to write, and RDI is the file descriptor, the device to write to. RSI is the characters, and RDX is the size. So here's what you have to do. Set RAX to 1, set RDI to 1 for standard out the console, push the string onto the stack, set RSI to RSP, so it'll point to the string, and then set RDX to the length of the string, and then call the syscall. That will make a print command. And so here it is in assembler. That's ABC, and I've got it here. So cat abc1.asm. There it is. So this is good. Here's the string I'm going to print, ABCDEFGH. So I push it onto the stack, and now I just do this. The length of the string is 8. The address of the string is RSP. Syscall1 is right. Standout has a file descriptor of 1, and I make the syscall. It should print out that character string A through H. Now I can compile and assemble with this stuff. And run it, and there it goes. ABCDEFGH backwards, and then a segmentation fault. So because I didn't do a proper exit, I just printed, and so now you can add the exit to it. Exit is just syscall 60. So, and there is an error code, but I don't care about the error code. So all I need here is to set RAX to 60, which is 0x3c in hex. 3 times 16 is 48 plus 12, and then call syscall. So this gives me ABC2. All right, and I see another question about the race condition. Why do you have to flip it back and forth? Well, you have to make it, what you need is you need it to point to the public file at the time of check and the secret file at the time of use. So you do need that transition. So you have to keep flipping back and forth to create that. You need those two conditions to be different. If you could time it correctly, then you only need one transition from public to private at that particular point. But since you can't time it, you just have to flip back and forth and hope to get lucky. All right, and so the ABC2 is here. .asm. All right, so it does the same thing, and then it does a proper exit. So when you run that one, abc2.out. There. Now it prints the letters backwards and exits normally, so it doesn't crash. Good. All right, good. All right. And now ABC, and to put it in order, you could just put the characters there backwards, so when they're reversed, it'll come out right. All right. And then you can use a data section. I don't think I'll keep demonstrating. This is all imitating stuff we've done in 32-bit. So here you can define a data section, which has your hello world followed by a line feed. And then you can print it out here. So now instead of pushing it on the stack and using the stack pointer, you can refer to the start of string 1 here, and it will find it in the data section. And then you can put in the length. The length of this is 13 bytes. So then you can make one that will print hello world and then go to the next line. And you can make an echo that will echo up to 10 characters and then return it and so on. So there's various challenges to do here. And then you can do what we've done before, a sloppy Caesar cipher that moves bits around. And I think we might have talked about this one before. I feel like we have. This one here, you store characters, and then you try to add 01, 01, 01, 01 to them, and you will find that you can't because that command does not exist. And if you look at the actual command that appeared, it only added a 32-bit 0101 instead of a 64-bit one, because I'm pretty sure we talked about this during lecture before. The problem is that instruction does not exist. You can add, these are the things that use 64-bit values. You can add a register to a register at 64-bit values, and you can add a register to a memory location at 64-bit values, but what I tried to do was to add an immediate value, and you can only add immediate values of 32-bit size. So the command I wanted to use to add an immediate 64-bit value did not exist, so you have to do it in 2 steps. You have to take this value. Instead of doing this, you have to do 2 lines. You have to put that in a register and then add the register to RCX. Then you'll get the 64-bit value. And when you get to ARM assembly, this is very common. So with that instruction, you can now make a sloppy Caesar cipher. So if you give it hello, it'll move everything forward 1 letter in the alphabet. All right. So we've talked about it in lecture. That's, I think, why it looks so familiar. And there's a few flags to find there. But anyway, that's what I wanted to show you about 64-bit processing. And I'm going to